Welcome to the deep dive. We're jumping straight into some pretty exciting developments in large language models today.
Yeah, we're looking at how to enhance reasoning in LLMs.
And specifically, we've got some research from Mistral to unpack.
That's right. A source detailing their first reasoning models. They call them Magistral Small and Magistral Medium.
And what's interesting is how they built them, right? From the ground up.
Totally. They developed their own custom reinforcement learning pipeline. Didn't just, adapt existing stuff or distill outputs from other models.
Okay, so our mission here is to really get into this source, figure out how they train these models for reasoning, pull out the key findings, and understand what makes their method, well, different.
Sounds good. Let's dive in.
So first off, Magistral. Tell us a bit more about these models.
Right, so Magistral Small and Medium are built on top of Mistral Small 3 and Medium 3, their base models. The big story, like you said, is this ground-up RL infrastructure they created just for this.
And the core idea was something called RLVR.
Reinforcement learning from verifiable rewards. Basically, training using feedback that says, yes, this answer is correct, or no, it isn't.
Focus on areas where you can actually check the answers.
Exactly. So think math problems, coding tasks, places where you can automate the verification. They really leaned into using just text data from these verifiable domains.
And this pure RLVR approach, using only text,
Yeah.
how did that pan out?
Well, according to the source, pretty impressively, especially for the larger model, Magistral Medium, they trained it only with RL on the Mistral Medium 3 base.
Just RL, no other fine-tuning step first.
Just RL. And they reported a huge jump in performance on the AME 24 benchmark. That's a tough math competition. Almost a 50% increase in pass at 1 over the base model.
Wow, nearly 50% just from RL. That's substantial.
It really is. It suggests their specific RL pipeline and reward system were very effective.
To do that kind of training, especially online RL, you need some serious infrastructure behind it.
Oh, absolutely. And they detail that. It's a custom-built, scalable system. It uses asynchronous workers.
Asynchronous, meaning different parts work independently.
Yeah. They have generators making the model outputs, verifiers scoring them, checking correctness, format, etc., and trainers updating the model weights based on those scores.
And because they're asynchronous, the training doesn't have to stop and wait.
Right. Generators can keep generating while verifiers are checking previous outputs, and trainers are updating weights based on even earlier results. It's designed for continuous training.
Keeps things efficient.
Very. They even mention transferring updated weights to the generators while they're in the middle of generating a response. Uses something called NCCL for fast transfers.
So the generators aren't using really old versions of the model.
Exactly. It helps keep the policy, the model's current strategy more up to date, which is generally better for online RL stability. They're trying to balance efficiency with being on policy.
That engineering sounds critical. What about handling multiple languages? They mentioned that too.
Yeah, their multilingual strategy seems quite neat. The goal was for the model to think and answer in whatever language the user prompted it in.
Even if most training data was English.
Correct. They did translate some training data, but the key was how they set up the task and the reward. They prompted the model to use think tags for its reasoning steps.
Okay.
And the requirement was that both the thinking inside the tags and the final answer had to be in the user's language.
And they enforced that with a reward.
Well, a language consistency reward. They used a fast text classifier to check if the prompt, the think part, and the answer were all in the same language. If yes, bonus points.
Clever. Simple, but effective.
Seems so. It incentivized the model to maintain language consistency throughout the whole generation.
The source also mentioned some findings that were maybe a bit surprising or challenged existing ideas about RLVR.
Definitely. One of the most interesting ones was about multimodal understanding.
Multimodal,
Right.
like vision and language. But they trained purely on text, right? Math and code.
Exactly. That's the surprising part. Despite training only on text-based problems, they found that magistral models maintained or sometimes even improved their performance on multimodal benchmarks.
Wait, how does training on text math problems help you understand images better? That seems counterintuitive.
It does, right? Their hypothesis seems to be linked to the complexity of the reasoning itself. By pushing the model to perform longer, more structured reasoning for text problems.
It learned a more general skill.
That seems to be the idea, that this enhanced capacity for structured thinking somehow generalized, even to tasks involving different modalities. We can maybe circle back to that.
Okay, definitely want to revisit that. What else did they find that was maybe unexpected? Something about smaller models.
Yeah, there has sometimes been a question mark over how well pure RL works on smaller models compared to really big ones. Maybe less stable or smaller gains.
But they found
They found their RL approach did give significant boosts even to their smaller 24B parameter model, Magistral Small. Though the best results for small came from a combination.
so not just pure RL for the small one.
For Magistral Small, the top performance came from first doing supervised fine-tuning, SFT, using reasoning examples generated by the stronger Magistral Medium, and then applying their RL process.
SFT followed by RL.
Right. So pure RL was great for the big model, but this SFT plus RL combo worked best for the smaller one. It suggests the optimal recipe might change with scale, but importantly, RL was still a key ingredient for the smaller model's success.
And they released Magistral Small.
They did, Apache 2.0 license, so people can actually use it and build on it.
That's great for the community. Okay, let's get into the nitty-gritty of the methodology. RLVR was the concept, but what specific RL algorithm powered this?
They used an algorithm called Group Relative Policy Optimization, or GRPO.
GRPO, what's special about that?
It's a policy-only RL method, which means you don't necessarily need to train a separate critic model to estimate how good states or actions are. It can sometimes simplify things.
And they tweaked the standard GRPO. The source mentioned modifications.
Yes, several key ones. For instance, they actually removed the KL divergence penalty.
The KL penalty. Isn't that usually there to keep the model from changing too drastically between updates?
Often, yes. But they found it wasn't needed or even helpful in their setup. Maybe other things were keeping it stable, or the reward signal was strong enough.
Okay, no KL penalty. What else?
They normalized the loss function based on the total length of generations in a training group. Helps manage variability, since responses can be short or long.
Right, stabilizes things.
And they paid close attention to how they normalized the advantage signal. It's basically the measure of how much better a generated response was than the average expectation.
Advantage normalization. Sounds technical.
It is, but it's important for stability. They tried different ways and found mini-batch normalization worked best for them, kept the updates consistent, avoided issues from outlier rewards.
Stability seems like a recurring theme. You mentioned earlier they wanted to encourage exploration too. How did the GRPO mods help there?
That came down to adjusting the trust region, specifically a parameter they call high.
Epsilon high.
Yeah. In methods like GRPO, this limits how much the policy can change in one go. By increasing high, they allowed bigger steps, bigger changes.
To explore more.
Exactly. To encourage the model to try less probable, maybe riskier, but potentially much better reasoning paths. It helped prevent the model from just settling on mediocre solutions too quickly, or losing its ability to generate diverse outputs, what they call entropy collapse.
So they use that epsilon parameter to balance exploring new ideas versus exploiting what already works.
Pretty much. They found carefully tuning this was their best lever for managing exploration, more reliable than adding explicit entropy bonuses terms to the reward, which they said they tried but found unstable.
Interesting. And they also filtered out some data.
Yeah, if a group of generations all got the exact same reward, they tossed it. No difference means no learning signal for this type of algorithm.
Makes sense. Let's talk about the rewards themselves. The R in RLVR. How did they shape the behavior?
They used 4 main criteria for the reward: formatting, correctness, length, and language consistency.
Okay, walk us through those. Formatting first.
Super strict. The output had to use think tags for the reasoning, box for the final math answer, and markdown blocks for code. If it failed, that basic instruction. 0 reward. Done.
A hard gate.
Yeah. If the format was okay, it got a small base reward and then moved on to correctness checking.
Which was the main event, I assume.
Absolutely. For math, they use simply a Python library to parse the answer in the box, normalize it, and check against the known solution.
Correct. But
Big bonus reward.
and for code?
Similar idea. Extract the code, compile it if needed, run it against test cases for that specific problem. Passed all the tests. Big bonus reward.
Was it all or nothing on correctness?
Yes. They specifically mentioned trying partial rewards for code, like getting credit for passing some tests, but found that a simple binary correct reward worked better overall. More stable, even though it ignores potentially useful info from partially correct attempts.
Practicalities of training, trumping theoretical purity sometimes. What about the other two axes, length and language?
For length, they added a soft penalty. As training went on, Models tended to get longer, so this discouraged excessively verbose answers, especially near the maximum allowed length. Just nudged it towards being concise when possible.
And language consistency.
That's what we discussed earlier. The fast text classifier checked if the prompt, the thought process, and the final answer were all in the same requested language. Match. Small reward bonus.
And the system prompt kind of laid all this out for the model.
The prompt set the stage, explaining the format. They also found that the phrasing mattered. Using casual language in the prompt, like be as long as you want, actually helped encourage exploration early on, even with the length penalty applied later.
So prompt engineering playing its usual subtle but important role.
Always does.
Circling back to the infrastructure for a moment, handling those variable generation lengths and mid-generation updates sounds complex.
Well, the asynchronous nature helps with variable lengths inherently, but the mid-generation update using NCCL, that's a specific piece of engineering to fight staleness.
Staleness.
Yeah, if a generator works in a long sequence using old model weights, the steps it takes might not be representative of where the policy has moved during that generation. Updating midway keeps it using a fresher policy.
I see. And how did they pack the data onto GPUs efficiently?
They used batching based on a fixed number of sequences, not tokens. Then within a batch, they used a greedy algorithm to group sequences of similar lengths together before feeding them to the GPU.
Sorting by lengths to minimize padding.
Exactly. Less wasted computation padding short sequences to match long ones. Standard trick, but important for efficiency.
Okay, let's shift to the data itself. What went into this RLVR system? You said math and code?
Right. Focusing on problems with checkable answers. For math, they started with a huge pile of problems, but filtered heavily.
No.
Like from maybe 700,000 down to about 38,000 curated samples. They checked formats, but also used models to estimate difficulty.
Filtering by difficulty.
Yeah, they wanted problems that were challenging enough to require actual reasoning, but not so impossible that the base models had zero chance. Kind of a sweet spot for learning.
Like finding problems just beyond the model's current reach.
Sort of, yeah. Problems where improvement was possible. For code, they used programming contest data mostly. The big job there was making sure the test cases were good.
Reliable tests were crucial for the correctness reward.
Totally. They had to filter flaky tests, validate them, sometimes generate new ones. Ended up with about 35,000 code problems, sometimes duplicating them for different languages like Python and C++ math.
Sounds like a ton of work just on the data side. Okay, experiments and results. Remind us of the main goals again.
Two main tracks, really. One, push pure RL as far as possible on a large model, Magistral Medium. Two, find the best way to get a strong reasoning model from a smaller base, maybe using insights from the bigger one, Magistral Small.
And Magistral Medium results.
Confirmed the big gains. Yeah. That nearly 50% ID24 boost, plus strong improvements on coding like live code bench and general STEM benchmarks, showed pure RL could work really well at scale for them.
And Magistral Small, the smaller model?
That's where the SFT plus RL combo shone. Fine-tuning first on reasoning traces from Magistral Medium, then applying RL, gave the best performance. Better than just SFT, better than just RL on the small model alone.
So the combination was key for the smaller scale.
That was their finding, yeah. Which was interesting because it slightly differed from maybe what others had seen, suggesting the path might depend on model size.
And the multilingual tests. Did the language consistency reward work in practice?
It did work. They tested Magistral Medium on translated A problems. The model could reason and respond correctly in other languages.
But was it as good as in English?
They did see a performance drop compared to English. So effective, yes, but maybe not perfectly closing the gap. Could be the translation quality or just the constraint itself.
Okay, let's move into the analysis they did. What deeper insights did they pull out?
One was this cross-domain generalization. They trained models only on math or only on code.
I tested on the other domain.
Yeah, and they found improvements. Training on math helped code performance. Training on code helped math performance. Suggests the RL wasn't just memorizing domain facts, but improving some underlying reasoning skill.
Interesting. Training for structured thinking helps structured thinking, regardless of the symbols.
Seems like it. They also did PCA principal component analysis on the model weights as they changed during RL.
Looking for patterns in how the model learned.
Right. They found the changes happened mostly in a low-dimensional space. And within that space, there was a clear direction linked to both higher rewarded and longer output sequences.
A length direction. So getting better rewards meant generating longer outputs.
Generally, yes. And they noted it scaled sort of logarithmically Getting much higher rewards seemed to correlate with disproportionately longer, perhaps more complex, reasoning chains.
And this could link back to the multimodal thing.
That's the connection they seem to make. This finding that RL pushed the model towards longer, more complex textual outputs along a specific weight trajectory, and that this correlated with reward offers a possible mechanism for why text-only training might boost multimodal skills.
Because it's fundamentally training for more complex processing.
That's the hypothesis. By rewarding these longer, more detailed thought processes, even just on text, the RL might be enhancing a general capacity for deeper reasoning that then transfers. And they did check multimodal benchmarks like MMMU, MMU Pro.
So improvements.
Maintained or improved performance, yeah, even though no images or multimodal data were used in the RL phase itself.
That is pretty remarkable. Did this reasoning training hurt other skills?
Apparently not. They report that things like function calling and general instruction following were maintained or slightly improved too. So the reasoning boost didn't seem to come at a cost elsewhere.
That's good news. It's always a worry with fine-tuning.
Definitely. They're also good about mentioning things that didn't work out so well. Like the partial code rewards we talked about, binary was better. And trying to use entropy bonus terms directly in the loss function to manage exploration. They found that approach unstable and preferred just tuning that high parameter in GRPO.
Sharing the dead ends is useful too.
For sure.
Okay, so wrapping up, Magistral represents Mistral really stepping into building these generally capable systems, specifically targeting reasoning using reinforcement learning.
Yeah, and the source gives a really detailed look at how they did it, their bespoke infrastructure, the GRPO tweaks, the reward design, the data work, and the findings themselves are quite thought-provoking.
Especially that pure RL success on the large model.
And the SFT plus RL for the smaller one.
Yeah.
But yeah, that multimodal generalization from text-only training is probably the most surprising piece. The idea that rewarding longer thought processes on text might be the key.
It really leaves you with something to think about, doesn't it? How does training a model so intensely on symbolic manipulation, on math and code problems, using RL that implicitly encourages longer chains of thought? How does that unlock seemingly unrelated abilities, like understanding images better? That connection, that generalization from complex textual reasoning to other domains, is a fascinating possibility raised by this work.
It suggests the depth or complexity of the internal processing might be more fundamental than the specific data type it was trained on initially.
A really interesting angle to consider. Thank you for joining us for this deep dive.